In this video, we will introduce the concept of a breakpoint and demonstrate how to step through Visual Basic .NET programs line by line to confirm program execution. We will use the wood cabinet estimate application that was previously created. You may want to build that application and return this video in order to follow along. With the form in the design mode, we will first double-click on the btn calculate object to enter into its subroutine. Then we will double-click the gray area at the start of the subroutine to set the breakpoint. Then we will save the program. Now that the breakpoint is set, we will debug the program. Notice that as the program begins execution and the form is loaded, nothing happens. This is because we have set the breakpoint on the click event of the btn calculate object. Therefore, the program waits for the event of clicking this button. So let's enter a value for linear feet and select the wood type. Now we are ready to click the btn calculate object. When we do so, notice that the code behind the form is opened up to us and that the program execution stops at the point where the breakpoint was set. From here, we can select F8 to move through the coding line by line. The first time we press F8, execution of the code is done until we reach a line of code that performs an assignment. In this case, the coding stops on the line in which our first variable, dec pine cost, is declared and initialized to 150 decimal. Subsequent presses of the F8 key moves the debugger through the next lines of code that either involve an assignment of variables or perform logic such as a comparison of values. Notice that after lines are passed in this process, it is possible to inspect the values being stored in variables by hovering over them with the mouse. This can be very beneficial in situations in which values do not seem to be being processed correctly and data type conversions may be necessary. As we continue to step through the program, we can essentially replicate the steps that the computer will take when executing our program. We can pay special attention to program flow and confirm that logic comparisons are being done correctly and the program is flowing in the intended direction based upon user input. In this case, we can follow the execution of the program through the nested if-else-if structure. It is highly recommended that as you are going through such a process of stepping through program code, that prior to the execution of each line or press of the F8 key, that you predict the value that will be stored in the next variable assignment and the path the computer will take when it reaches a decision point. If you see any unexpected results, you should stop execution and reevaluate your coding or your interpretation of the logic. It could be the case that the syntax of your coding is correct, but the logic is not correct. The compiler will not catch logic errors, so you must be very critical of your own work and expect to find issues that need to be corrected. Of course, full testing is required to ensure programs are properly debugged. This requires the development of test case scenarios that cover every possible situation. Large programs are tested by teams skilled in this process rather than the program development team. One of the main reasons for this is that when we are writing code, we are doing so with the intention of writing it correctly and are not always able to see flaws in our own reasoning. Still yet, though, the compiler options to catch syntax issues and this process of debugging line by line can be very valuable as first lines of defense in removing coding issues. When we are satisfied with the program execution, we should remove the breakpoint. This can easily be accomplished by clicking on the breakpoint that was set. As always, it is a good idea to save the program after such changes.